Hey, so today I just realized my section number is wrong. We are going to move forward to section 32-2, which talks about arc length. So I'm going to try to make this a little bit bigger. My camera tends to be slightly better focused. Now it'll make a liar out of me. I'm going to walk you guys through how to find arc length, understand the concept. Of course, we'll do the even problems together, and then you guys will be tasked with the odds. But I kind of want to go in order of your assignment, so that way maybe as you have it out, you can kind of keep pace with me and you know where to pause in the video if you ever need to listen to it again. And guys, please don't hesitate. Let me know how I can help you. Send me an email. Please respond to the surveys. I know my questions are silly. I literally sit in my classroom at home, which is my dining room, on Sundays, and my husband's doing something in the kitchen, and I'm like, I need a survey question. Do you want a math question? No, I don't want a math question. They do that in their homework. And he, I think, wonders who I am sometimes with the questions that I ask you guys about. And because I am in the kitchen, they may be food related because I think I'm always hungry. So here we go. Let's talk about this problem. But again, I appreciate you guys doing the survey questions and keep it coming and let me know how I can help you guys. So we're going to take a look at problem number 2. It asks us to find the area of this circle. So in our last video, we took a look at area, and area was pi r squared. Well, here we have a diameter of 8, which means that each radius is 4. So area will be pi times 4 squared. 4 squared is 16, so we will leave that as 16 pi miles squared. Now if you notice the directions, it says give exact. That means leave pi in the answer, and then approximate, that means decimals. So when I grab my handy dandy calculator, I'll use 3.14 for pi. That would give us 50.24 miles squared. So this is the exact with pi, and then the approximate with the decimal. Number 4 is a little bit different. We are given the circumference. If that will focus, that would make my life a lot better. Maybe if I start writing, it'll help. So our circumference, remember, is equal to 2 times pi times r. There we go. So that circumference is 62.8. I'm going to set that equal to 2 times pi times r, and I'm going to solve for r. And I'm actually going to do this one just in decimal form or approximate form. So I'm going to divide both sides by 2 and both sides by pi. And I'm going to put my calculator screen right in front. I don't want to block quite everything in your view. So we're going to take 62.8, our circumference. Remember, that's the walking distance around the edge of the circle. And we're going to divide that by 2. And then we're going to divide by 3.14. And that's going to give me a radius of 10. Well, if my radius is 10, now I can go find the area, because the area is 10 squared times pi. Well, that's 100 pi kilometers squared, so I guess I will do the exact value. And then if we do 3.14 for pi times that 100, which was 10 squared, we get 314 kilometers squared. So you guys have a couple of options on those answers. So that's just a little bit of review. I'm going to scoot that away, and we are going to talk about finding the area of arcs. So I'm actually going to kind of bounce around a little bit. I hope that doesn't mess you up, and of course everything just got fuzzy. Arg. I'm going to draw myself a circle. So I want you guys to understand the concept of what I mean by an arc. So an arc is a portion of the curved edge of my very imperfect circle. When we think about that, that's like a part of the circumference or a part of the perimeter. When we think about the concept of a sector, it's not too bad. when we think about a sector is addressing a region. Think like section or a portion of the area of the circle. So this is what I want you guys to think of when we talk about a sector. So we're going to have a couple of different tasks ahead of us. We're going to be asked to find the area of a sector, and that'll match with problems 5 and 6. And then we're going to be asked to find the length, like perimeter or portion of circumference, for the arc. So those are two different ideas. So I'm going to put my worksheet back in front of me, and we're going to walk through, when it clears up, the area of a sector. So looking at problem number 6, and I know you can't always look at it. I hate this thing. You're probably really sick of me complaining about it. I know that I'm lucky to have it, but I'm going to whine because it doesn't work perfect. Look, it does it on purpose. It hates me. So when we are asked on number 6 to find the area of the sector, I want you guys to be thinking about the mark where the arrow is. That's telling us the sector of interest. So we want to find the area of this portion of the circle. It's not the whole stinking area of the circle. Well, we know that area is pi r squared. We just kind of played with that with the problems above. But I don't want to find the area of the whole thing. I just want to find the area of this portion, thus called the sector. So what we're going to do is we're still going to take pi times r squared, but then what we're going to do is we're going to focus on this section, this sector of the circle. Well, we're looking at a 135-degree section of the circle. So I'm going to take that and I'm going to turn it into a fraction. A whole circle is 360 degrees. So we're looking at 135 degrees, that part of the circle divided by the whole thing. So when you think of the sector, this is the space that we're looking at, but then we have to account for the fact that it's circular and that it has a radius of 14. So the directions ask for us to give exact and approximate answers. And I'm going to walk us through a little bit of our calculations to do that. Here comes the handy dandy calculator. So I'm going to do 14 squared, there it is, times 135 over 360. And you'll notice that I'm going to protect that 135 over 360 in parentheses because I really want to be able to see that as a sector. And I'm going to hit enter. And I know it's a decimal, but that's okay. So that is 73.5 pi. When we talk about leaving it as an exact value, we're leaving pi. Pi is irrational. It's not really 3.14. It goes on forever and ever and ever and ever. And so we don't want to chop it off at 3.14 all the time, but we don't want to write all that stuff because we would literally never stop. So when we talk about leaving it as an exact answer, we're leaving it in terms of pi. Because we were talking area, it will be kilometers squared. So this is the exact value. Now, if I want to find the approximate, we will take that times 3.14 because we're approximating pi, and that is 230.79 kilometers squared. So those are our two different values. And if you round that 0.79 to 0.8, fine. We're good. All right, moving on. So when we talk about finding arc length, we're not finding the space or the area. We're finding the walking distance, kind of like perimeter, which we called circumference in the circle, of this section denoted by the direction of the arrow. So arc length, I want you guys to think circumference. 2 times pi times r. But we aren't walking the whole distance of the circle, we're walking this yellow highlighted portion. So we need to address how big that portion is compared to a whole circle of 360. So I've kind of blended a formula with an actual example, Kind of shame on me. I'll get it cleaned up here in just a second. So we're going to do 2 times pi. Our radius is 17, and the arc length that we're looking at is the 90 out of 360. Okay, when you read your directions, it says to the nearest tenth. So I'm not going to use I am going to use 3.14 for pi. I'm not going to leave the pi in this. So here we go. 2 times 3.14 for pi times 17 times the section of the circle we're interested in, that arc length, so that part of 90 out of 360. And I'm going to round that. We will get 26.7 because it says to the nearest tenth, which is 1 spot past the decimal. And this was feet. We just found our very first arc length example. So I'm going to put over here a little formula. Arc length is 2 times pi times r, which is the concept of circumference, times your degrees that you're interested in, that's the degrees, over 360 for the entire circle. So that set of the parentheses is really talking about that yellow arc piece. Well, let's do 2 more because we've got 2 more to do. This one we're looking at, get my highlighter ready. When you look at the direction of the arrow, we're looking at this arc length distance right here. So we're going to have our radius, 2 times pi times our radius, times the section of the circle of interest, so 195 out of 360. 2 times 3.14 times 4, 195 over 360. Now you'll notice I didn't put the little multiply dot between the 4 and the parentheses. The calculator understands that concept of order of operations and you don't really have to do it. And that'll give us about 13.6-ish centimeters. That is the length of this walking edge around the arc. Number 12, very similar. Follow your arrow. Take a look at your arc. Let's roll. 2 pi times 13, so that's our circumference, times the portion of the circle of interest. 210 out of 360. Calculator time. Okay, there we are. We are looking at about 47.6. Was that kilometers? Kilometers. That's not so bad. And you might be thinking, okay, did we have an area or a formula for the area of the sector? You know, I'm realizing I didn't write it down, so I will. For the area of a sector, that's a really weird bubble, but we're going to roll with it. It is pi times r squared times the degree or angle of interest over 360. There you go. All right, take care of yourselves. I'll talk to you soon virtually and whatnot. Please let me know if you need any help or if there's anything I can do to support you. Bye.